Hello Candles, welcome to Candela Learnings. My name is Albert Bonnie. Today we move on to a new chapter. In fact, the last chapter of mathematics for you in grade 10. And you have learned bits and parts of it in your previous grade. And this chapter is just to build upon it. Not a lot, but again, just basic building blocks. The chapter name is probability. What we are going to learn today is theoretical and experimental probability. To begin with, as always, I have a small experiment for you. I have a box and three bowls. I have an yellow bowl, a red bowl, and a blue bowl. Let me show them each to all of you so that you believe me. What I'm going to do is, it's a simple game. I'm going to put them in this box. This box is already empty. So I'm going to put them here. All three bowls of same shape, different color, and the game is I'm going to do two tries. The first try, I will take a bowl from this box without looking three times. In the second try, I will take a bowl from this box five times. And you have to guess, before me doing this, how many times will I get a blue bowl? I will repeat it one more time. I have a box full of three bowls. In my first sample, I will take one bowl from it three times. In my second try or second sample, I'll take one bowl from it five times. You have to guess how many times will I get blue bowl in the first sample and also in the second sample. Alright, I hope it's clear. It's a guessing game and let's see how many of you get the guesses correct. So I'm taking all the three bowls out again, the blue, the red and yellow, and I'm keeping it inside the box, and let me do a really good shuffle, and I'm not gonna look where the bowl is. Okay, I'm just opening it and taking a bowl. Let's see what do I get. I get an yellow. Okay, try number one, yellow. Let me close it, give one more nice mix to it, get a red ball. Okay, I haven't got a blue ball yet. Let's see if I get a blue ball here or not. I get a red ball again. So in my three tries, I got two reds, one yellow and zero blue. Alright, now let me see how many times will I get a blue ball when I'm trying it five times. Okay, 1, 2, 3. Get a blue ball. So I get a blue. Again a blue ball. So two blue balls already. A red ball. Three tries over. Yellow ball. So I've got two blue balls, one red and one yellow yet. Let me see if I get one more blue ball here. Oh yes, I got one more blue ball. So I got blue 1, 2, 3 times. I got one yellow and one red, which tells us that there is no clear pattern for this. Alright, I'm wondering how many of you actually guessed that I would get three blue balls when I took the ball from it five times. Either way, let's play with this data a little. So I'm going to keep this box away so that we are not distracted. So let's check what is the experimental probability of getting blue in case 1. What do I mean by experimental probability? When I did this experiment with this box, how many blues did I get in case 1? In case 1, I got 0 blues, and how many tries did I have? I have 3 tries. So the experimental probability here is 0 divided by 3, which is 0. Now let's look at what is the experimental probability of getting blue in case 2. In case 2, how many blues did we get? We got 3 blues. And how many tries did we have? 5 tries. So 3 blues out of 5 tries. So the experimental probability there is 3 by 5. This value we have received after doing the experiment. Say if I wanted to actually know how many blues will I get if I do it 10 times or 15 times or 20 times, I will actually have to do this experiment where I take the board 15 times and 20 times. I mean, if you're the one who's doing it, I'm sure you'll be bored. I mean, if there is someone who's watching it, I'm sure they're definitely bored. So it's a little difficult. Now, let me show a few examples of few very boring people. There are few scientists which are mentioned in your textbook who have tossed a coin, say for example, 4040 times, and they saw that they got head 2048 times. So the experimental probability that they got there was 0.507. How did they get that? They divided 2048 by 4040. Now there was another even more boring person who tossed a coin 10,000 times and he got 5067 heads, where again the value came somewhere close to 0.5067. Then there is this guy. I can't imagine how he did this. He tossed the coin for 24,000 times and he got hit around 12,012 times. So the experimental probability there was 0.5005. Let's look at these values that I've marked here. These three values, when you look at it, can you tell me to which value is this three values closer? Like if I have to put all these three values into one, what is that one value that I would put? Sure, you're all thinking it is 0.5, right? Like all three values are almost close to 0.5. So all these experimental probabilities, that is when someone tossed a coin for, I don't know, 10,000, 24,000 times, etc., etc., they got values which are closer to 0.5. So what is the significance of the 0.5? The 0.5 is what we call as theoretical probability. Now, what is theoretical probability? Theoretical probability is when all outcomes are equally likely. That is, when you toss a coin, what are the two options that you have? You have a head or you have a tail. Now, when you toss a coin, you get a head or a tail. So, out of the two outcomes that you have, for the probability for getting a head is 1 by 2, which is 0.5. This is something that even if you do it 2 times, 3 times, 4 times, 5 times, you can say that theoretically the chance for getting a head or a tail is 0.5. But when you actually do the experiment, say for example, like this guy did for 24,000 times, the number is somewhere closer to that, not exactly that number. Say for example, when he did 24,000 times, he got number of heads somewhere close to 12,012. Now the exact value would have been 12,000, but he got heads like 12 times more. But for our simple calculation, we can focus on theoretical probability. That is when all outcomes are equally likely. Say for example, in the case of our first experiment that we did, where we took three balls, one blue, one red, one yellow. What was the chance of getting blue? Three balls, out of which one ball was blue. So the probability for getting blue there was 1 by 3. What probability? Theoretical probability. When we did it experimentally, we got values ranging from 0 to I think 3 by 5, which is somewhere around 0.6. So this is the difference between theoretical probability and experimental probability, where we will focus mainly on theoretical probability in this chapter. So what is an event? Event in probability can be defined as a set of outcomes of a random experiment. Too difficult. I don't understand why we need to look into that definition. Just look into the bottom text. Simpler words. Any outcome that we are focusing is an event. Say for example, tossing a coin. I am looking at the probability of getting a head. So getting a head is an event. What if I was looking for the probability for getting an tail? Well, then my event is getting a tail. I am throwing a dice. I am looking at how many twos will I get. then the event there is getting a 2. So any outcome that we are focusing on is basically an event. Don't complicate it. It's just as simple as that. Alright. Now I want you to use something that you have learned in your previous classes, and let's see how many of you remember this. I've given you 6 cases jumbled up, and I want you to divide them into equally likely outcomes and not equally likely outcomes. I hope you remember what equally likely outcomes and not equally likely outcomes are. If you don't, I'll give you a quick hint and then I want you to just make a good guess. Equally likely means the chance for happening all the outcomes are equal. Not equally likely, the chance for getting each of the outcomes are not equal. That's it. Now, you don't have to know any formula, just use your logic, look at these things, take 10 seconds to do this and classify them into equally likely and not equally likely. Do it right now. Alright, I hope you have done it. Let's check if your answers are correct. The equally likely outcomes are tossing a coin, rolling a dice, true or false questions. What does that mean? When I toss a coin, how many chances do I have? I can either get a head or I can get a tail. The chance of getting a head and a tail definitely is equal. You can't guess. It is exactly because of this reason why at the start of an IPL match or any cricket match for that matter, they toss a coin. That way, each team has the same chance of getting whichever side that they're calling. Rolling a dice. In a dice, how many sides are there? There is 1, 2, 3, 4, 5, 6, and numbers are written. Now, each side has the same chance of coming up. So, rolling a dice is also an equally likely outcome. True or false question? You have a question, it's either true or false. There is no other way that it could come. So, true or false statement is also an equally likely outcome. Let's look at not equally likely outcomes to kind of understand why they are different. Select a 25-year-old from all the people in India. Now, are all the people in India having their age distributed evenly? That do we have equal number of 25-year-old people, equal number of 26-year-old people, equal number of 50-year-old people, equal number of 80-year-old people? Of course, no, right? I mean, technically, right now, India has more young people. So, the chance of getting, if I am taking, say, 100 Indians and randomly, and just when I pick one person, for that person to be young person, the chances are more because technically India is having a higher population. So, point B, it's not equal the chance for getting a 25-year-old when I'm picking. So, it is not an equally likely outcome. Next is now when you look at rolling a matchbox, if you have noticed a matchbox, you would have seen that there are two sides which are having big rectangles and other four sides around it are small rectangles. So, when you roll it, try it once. You'll see that the chance for that bigger rectangle to come is always high. Whereas if you look into a dice, all sides are of equal shape. So if I roll it, the chance for getting all sides are same. So it is also not an equally likely outcome. Drawing a bowl from a bag that contains balls of different size and different colors. Different size and different colors. Now different colors we can understand, but different size, I mean when I'm putting my hand in, I know if it is big or small or whatever, right? I have a choice to choose which one that I can select there. So this one is also a not equally likely outcome. So coming back to our original point, that is theoretical probability, also called as classical probability. The theoretical probability of an event E, written as P of E, is defined as P of E is number of outcomes favorable of E divided by number of possible outcomes. Too difficult, guys. I'm going to do an example and from there it will be easy for you. Don't have to worry about this particular point. Few points for you to note. The value of probability will always be less than or equal to 1 and greater than or equal to 0. And I'm sure you know this by now. The denominator when we are finding P of E is always all the number of outcomes. That is, all the outcomes that are possible are written in the denominator. So, the numerator, which is an event, can never be more than all the other outcomes. Say, when I'm tossing a coin, I can get a head or a tail. So, there are two outcomes. Now there is no chance that I'll get a head 3 times. That's not possible when I'm tossing a coin. So which means that the value will always be less than or equal to 1, and it can never be a negative value, because I mean, come on, it has to happen. If it has to happen, it's a natural number, so it's never less than 0 also. And we could also write probability in terms of percentages, of course, right? Like tossing a coin, there is 50% chance for head or tail. You already know it instinctively. So zero point 0.5 or 1 by 2 can also be written as 50%. So nothing, guys, this chapter is all about you thinking intuitively rather than trying to somehow by heart what it is. Let's look at few examples so that this concept is clear. Find the probability of getting a head when a coin is tossed once, and also find the probability of getting a tail. All right. Now, what are outcomes when we are tossing a coin? When we are tossing a coin, we can get a head or a tail. So, what is number of outcomes? The number of outcomes here are 2, head or tail. Now, what are they asking you to find? They're asking you to find the probability of getting a head. So, what is our event E? Event E is getting a head. So, the probability of E will be number of E divided by number of outcomes. What is number of E? That is, how many number of times will you get a head when you're tossing a coin once? I mean, you can get a head once, right? Like that's the only option. So number of E will be 1 and number of outcomes will be 2, which would be equal to 0.5. Whereas they are also asking what's the probability of getting a tail. The getting a tail, let's see, the event E is getting a tail. When you're tossing a coin, guys, what's the chance of getting a tail? Well, you'll get a tail once, right? So n of E by number of outcomes, which would be equal to 1 by 2, again 0.5. Alright, let's look at a little bit more slightly difficult question. A bag contains a red ball, a blue ball, and an yellow ball. Same example that we did at the beginning. All the balls being of same size. Kritika takes out a ball from the bag without looking into it. What's the probability that she takes out an yellow ball, a red ball, and a blue ball? Okay, let's look at what are the outcomes that we are getting when we are pulling a ball from a box. Pulling a ball from a box, I can either get a blue or a red or a yellow. So my outcomes are blue, red, or yellow. How many outcomes do I have? Number of outcomes is 3. So the first question is, what is the probability that she gets it yellow? So the event E is getting a yellow. So here is a tip for all of you. Whatever they are asking, that is your event. And what all the possibilities, if you list down, there you'll get the number of outcomes also. So what is the number of E? When I have a box with 3 balls and I'm pulling one, getting an yellow, I mean, I can get one yellow, right? There's no chance I can get 2 yellows. So number of E is 1. So probability of E is n of E by number of outcomes, which would be equal to 1 by 3. Let's look at the second option. That is, or second question. What's the probability of getting a red? Number of E, I'm pulling a ball out of a box. I can maximum get one red. So number of E is again 1. Probability of E would be n of E by number of outcomes, which would be equal to 1 by 3. What is your guess? What is the probability of getting, if the event E is getting a blue ball? What do you think is the number of E? Of course, it is 1. What do you think, without doing any calculation, what do you think is the probability of E? Of course, I'm sure you are already thinking the answer, but let me write the equation 1. And there's a reason why I do this. It looks boring, right? I'm writing the same step again and again. But when you're solving this question, if you are identifying what is the event E, if you're writing what is the number of E, and if you're writing the equation, you do this, even if your final answer is wrong, you get some marks for your attempt. If you just write the answer, I mean, how will the examiner know that you've actually gotten it? We can also assume that you've copied it, even though you may not have. So always write the steps when you're solving these questions, no matter how easy it looks or sounds, no matter how boring it feels. I hope you understood the idea of probability. In the future sessions, we will look at more examples of probability. So see you again in the next session, where we look at few more questions and few more, I would say, a little bit more difficult questions, but not too difficult. Till then, see you and bye bye.